Good morning, everyone. Thank you very much for inviting me to this workshop and organizing this wonderful group. I apologize that I arrived late and I'm leaving a little bit early. So if you have any questions, please do feel free to come and find me during the breaks, or if you need anything after the workshop also. My email is there, kwhang at nsf.gov, and feel free to contact me anytime. I just want to go over very quickly a little bit about what we do at NSF and how we're organized. A little bit about how we see these very growing, rich set of interactions between brain research and computing. And then also, with that as a segue, say a little bit about some of our current funding opportunities and how they're structured. First of all, NSF as a whole sits in this very interesting space between the general public and all areas of science. We sit in a fairly privileged position. On the one hand, the public has, since 1950, given us the authority to fund basic research in all areas of science and engineering. This is currently to the tune of just a little bit over $7 billion a year. We account for about 25% of the basic research at U.S. academic institutions. In addition, we have developed strong relationships, especially throughout the academic community. And as a result, we play a role in government where essentially we can sort of serve as a broadband detector of new signal coming out from all different areas of science and engineering. We are primarily a bottom-up organization accepting ideas from the field. And we want to be open to innovation coming from all different sorts of directions. So if you had to sort of characterize our mode of operation in a nutshell, we are driven by what's coming in from the field. We offer very broadly scoped opportunities, largely with the idea that some of the best things that come in are all going to be things that we couldn't possibly have anticipated. So we don't want to filter things out in that regard. And then, as I mentioned, that we are open to basic research in all areas of science and engineering. The other thing that's interesting about NSF is that we are also organized according to scientific fields. And if you wanted to kind of zoom in on our org chart and sort of abstract a little bit, you would see that the bread and butter of our work, the scientific directorates, are all organized into disciplinary fields, traditional disciplinary fields, just like what you would find at the academic departments in any U.S. university. And you might ask yourself, well, so where does brain research fit into any of this? And the answer is really in a lot of different places, and there are sort of both good and bad things about that that I guess I want to get you attuned to. Certainly there's basic neurobiology going on in the biology directorate. There are a lot of interests in mathematical and physical statistical aspects of brain research, computational neuroscience and neurally inspired computing in the computer science and engineering. And also a lot of intersections with social, behavioral, and economic sciences and education. And one thing is that this means that if you're looking for funding opportunities in this area, they come in a lot of different flavors. And a lot of those opportunities are very much along that that vertical orientation on that diagram. What are you going to be doing for physics? What are you going to be doing for computing, et cetera? But we also have some cross-cutting opportunities, which I'll be telling you about. You can think in a way of our technology interests as also being cross-cutting in a similar way. And in thinking about how we're organized and how we fund things, the nature of that review context and the program context is fairly important. So for the purpose of this workshop, we're mostly focusing in that sort of subspace, and you can think of our interests at NSF as being very broad and interested in general in how it is that what we know about the brain can influence, can enable our understanding or can enable brain-like computing machinery, as well as what we're learning from computing, giving us machine-like or machine-enabled understanding of brain processes. So in this general space, I think one of the things that we need to think about is, well, what do we actually know about any of these things? What do we actually know about how the brain works and so forth? And you might say, well, we know a lot, and yet we also know very little. Certainly we have seen huge advances in our understanding of brain structure, brain activity, computational mechanisms, system function, architecture, et cetera. But we're a long way from having a real principled understanding of all of these things. And which is not to say that we don't know enough for it to be useful. But the second question in general is what of all these things that we know is useful or feasible to really abstract out? It seems as though we know a lot more than sort of highly simplified notions of just spikes, synapses, connectivity, et cetera. But it's unclear which of these aspects of our current knowledge are really going to be useful and are really understood in a good enough way that we can abstract out principles. And then finally, we have to ask, well, does this knowledge help? Does it help in principle, and does it help in practice? It's certainly possible that we can apply certain types of knowledge to engineered systems, and we can understand a lot in terms of principles, but in practice, they may not actually get us a step further than where we are already. It's also possible that there are sometimes these discrepancies between what we think ought to work and what does work, and vice versa. And in general, I think one of the things that we need to think about is sort of along that pipeline, how can we sort of smooth out the transitions a little bit so that rather than having folks at one level saying, here's what my result is, throw it over the transom, have more integrated approaches so that that people who are working on one side of the house have a more principled understanding of what they need to be looking for that would be potentially useful, and so forth. So I think right now the fairly fragmented nature of the community is certainly something that we can think about. We have been intensely interested in getting input from the community on what we ought to be doing as an agency in this space. I should have included there's a URL for this, but it's overly complex. If you Google CCC Brain, you'll see one recent workshop that we had involving fairly broad representation in the computing research community, exploring what kinds of interfaces are possible and likely to be productive between brain science and computer science. So we're very interested in getting your feedback and developing these sorts of opportunities further. Getting back to my map of NSF, as I mentioned, we have opportunities in this area that are both sort of more disciplinary oriented and more cross-cutting. This is just a sample of some of them. Within what we call the Robust Intelligence Program in the Information and Intelligent Systems Division, we cover some areas of computational neuroscience, a lot of machine learning, a lot of neuro-inspired vision and robotics. We have the Software and Hardware Foundations Program, which includes some work on neural-inspired systems, and likewise the Algorithmic Foundations Program. In engineering, you'll see a lot of neuro-oriented work in biomedical engineering, in the electrical engineering programs, and also in the Emerging Frontiers Program. This is actually a program that selects different cutting-edge engineering topics, and they have different topics every year. And you'll see in the history of this program, there have been a number of neuro-related engineering topics. As I mentioned, for most of these programs that are sort of oriented in this vertical direction, the context of the program and the type of distribution of proposals, the competitive context, is really along what the foundational contributions are going to be for computing and for engineering. There's not, we don't have anything that is sort of sitting at one intersection where there's sort of a competition just of sort of proposals of neuro-oriented projects of a particular type. In contrast, we also have these cross-cutting programs. Many of you may be familiar with collaborative research in computational neuroscience. That's not necessarily getting at all the aspects of what's covered here. We also have something that's new called Integrative Strategies for Understanding Neural and Cognitive Systems. This is a new program that we've just started that's part of NSF's response to the BRAIN initiative. And then finally, we have a program, Cyber Physical Systems, that also covers some territory in this space, which is a long-standing collaboration between computer science and engineering. I just want to say a little bit more about our new program that's part of the BRAIN initiative, this Integrative Strategies for Understanding Neural and Cognitive Systems. This is really looking for transformative, integrative research that is aimed at getting at previously intractable challenges. And there are two themes that have been so far announced that are part of the current competition for this year. The deadline for this year has already passed. But both of them, I think, are highly relevant to this workshop. One is neuroengineering and brain-inspired concepts and designs, which covers all aspects of areas where insights from neuroscience and cognitive science can combine with insights from new areas of technology to bring about significant innovations. So this includes, all matter of, imaging, recording, computing paradigms, brain-computer interfaces, neuro-inspired systems writ large, where you have some real innovation both on the brain side and the technology side. The other theme that is already active is individuality and variation, which includes an interest in variation and statistical issues at all aspects of the system, from people and how they behave, down to signals in the brain, role of noise, and general statistical and modeling issues, getting at these aspects of understanding neural and cognitive systems. This is a work in progress, this program, so you can anticipate change over the next few years. We have already announced some new themes that we're planning to roll out, one of which is cognitive and neural processes in realistic complex environments, and the other of which is data-intensive neuroscience and cognitive science. You can look at the solicitation for more details, but basically we have one proposal type, which is sort of a small mid-scale type of proposal, projects of up to $1 million. We have something called a Core Plus extension, which means that supposing that you're doing some basic engineering research or you're doing some basic computing research, and there is some aspect of it that you think has application to neuroscience or cognitive science, you can actually get that proposal run through your regular core program, because that's really the group that has the expertise to evaluate it and sing its praises. But you can also specify that there's some particular new aspect of this problem that you want to apply to neural and cognitive systems and get additional funding for that. So that's just another funding mechanism that may be applicable for a lot of the research that's represented in this room. And then finally, there's also a larger scale award under this program that is anticipated, and you should wait for the next issuance of the solicitation to learn a little bit more about that. In general, we have a website, nsf.gov /brain, that has information about NSF opportunities in neuroscience. Generally, this gets updated reasonably frequently, so also do check there for more information about what we're doing. Thanks. Any questions?
Oh, sorry.
Oh, sure.
One question. So, there are a few funding agencies, support this kind of research. I just want to know how the NSF position itself, among all the opportunities by comparing some other funding agency.
Okay. I think the main thing that we could say for NSF is that we really try to be as broad as possible and tend to look on a longer time horizon in terms of distance to impact. So to that extent, we're very open, but we talk to the other agencies as well. I mean, you'll see most of the programs from the other agencies tend to be a little bit more targeted.
I have a kind of a general question. At the beginning of your talk, you mentioned that NSF's been trusted by society, or at least American society, to fund basic science. And so my question is, how do you see cognitive science or understanding the brain as impacting society? Where's the benefit? Why would society want to fund that?
Well, that's actually it's a good question, because I think that also the way that brain science impacts the different, even within the different fields of NSF, they're all sort of different intersections that are primarily useful. From our perspective in the computer science directorate, it is. I would say mostly through looking at technology applications and looking at how understanding of neural systems helps us understand this computational device and in some sense get a better understanding of computing at a much more general level, but also the, the desire to capture what's smart about neural systems and exploit that. In terms of exactly, where the most beneficial applications are, I think we can all imagine a lot of them, but some of this remains to be seen in practice. Okay, thank you.
Thank you, Ken.